Hello, everyone. As Rachel mentioned, if you have any questions, please use the Slido code that's here and will be on each of my slides going forward. And if a question comes up, I can stop and address it during the session itself. So this session will be talking about one of the new services that we have as part of our offerings from UBC ARC, and that is our ARC OnDemand service. ARC OnDemand is a web-based interface that connects to our local computing cluster, Sockeye, and provides an easy web-based access to a lot of the features that normally you would have to use command line to interface with. So a little bit about who we are and what we provide. UBC ARC is the Advanced Research Computing Department. We support over 2,000 researchers across 400 different research allocations. And that includes both on-site at UBC Vancouver, as well as at UBC Okanagan and other sister colleges that are part of various allocations on our systems. We provide assistance and access to both our on-campus resources as well as assisting researchers with connecting to our national resources. And Sockeye is our on-site system that we manage and has roughly about 15,000 CPU cores. Now, our system has been up and in operation since the fall of 2019, when we launched the system and basically started bringing researchers on to start having an on-site location to run their workflow. Since then, we've reached roughly about 7 million compute jobs since the start of that service that have run on our system. And most of our workloads have been run through what we use as the Slurm scheduler. Now, if you're familiar with HPC systems or you took my Bash course on Monday, you'll know that most of the time when we're interfacing with a system like this, we're going to connect using SSH and have a terminal interface using a Bash shell or another shell environment. And this is actually in contrast to what a lot of applications and such use in the world, not just in the research space. If you're connecting to most services these days, you're either using an application or a web browser or some sort of piece of software that's specifically designed to be interfaced with keyboard, mouse, and a lot of being able to click through things. Research software, depending on department and faculty, has quite a bit of research development that's been done over the decades. So some of them have actually started out in history as being purely command line tools. Whereas, and this is like chemistry, physics, mechanical engineering, since they have been heavy users of compute since the 80s, they have kind of developed into that ecosystem of during the 80s, everything was command line entirely. But nowadays, we have a lot of researchers and research programs who are starting to use more computing interfaces that are not command line based. And running those on a traditional HPC is either not possible or substantially harder, of either trying to forward that graphical interface out or having to learn an extra set of language on top of it to run the command line version of the same tool. So one of the services that we looked at integrating is Open On Demand. And what this is it is a web-based interface for HPC systems. And it's developed by the Ohio Supercomputing Center and gives an easy way for researchers to go through and do common tasks that they would normally use on a command line on an HPC system. So things such as moving files around, submitting jobs with the scheduler, even doing things with like either command line tools or actually having graphical software to interface with. All of these are things that we can now offer through Open On Demand as part of Sockeye and our ARC services. So that is mostly just kind of like a little introduction as to what Open On Demand is and what we provide for it. I'm just going to step into our interface that we have on Sockeye itself. If you are a member of the Sockeye system and have an allocation, you're free to follow along. This is a service that's been up and running since pretty much the start of April. So you can basically do all the same actions that I'm doing to follow along. If not, unfortunately, you do have to be a member of Sockeye to reach our interface. So unlike the bash session, we don't have any guest accounts spun up for it. But I will be going through and narrating as I work through it here. So let's see here. I'm already logged in, so let me quick. Just force myself to log in again. So in a browser, if you are on a campus network, much the same as you would connecting to Sockeye, either through the UBC VPN or in my case, off of the campus Wi-Fi, I can connect to ondemand.arc.ubc.ca and it'll prompt me for my CWL login to ARC OnDemand. And logging in, it'll give a quick prompt there for potential multi-factor authentication. I'm already signed in, so and have signed in recently, so it automatically passed through that. And once you get through logging in, we're presented with kind of our splash page and our landing page for our UBC ARC OnDemand. And from here, we have message of the day for researchers and links to kind of our technical user documentation around this, as well as the main part of ARC OnDemand here is this navigation bar at the top. And this navigation bar gives us access to all of the different features that are available on the system. So the first one we're going to look at is how do we manage files? And if you are familiar with working with files off of a command line interface, either using SCP or tools of the command, like moving files around with bash command line tools, this may feel easier if you are more oriented to using a graphical interface. So from the files drop down, we have basically a selection of your main directories. In my case, I have my project and Scratch directory for my allocation, as well as my home directory for my user itself. And when I click on one of those, it will drop me into that directory. And I can see all the files that I have within that directory just as part of the web page. I have a lot of directories here for various work, but we can see at the top it says that I'm at my home directory, and each of these files is basically set up as a link as well as listing their size if they're a file, when they were last modified, as well as other information that you would get out of LS like permissions and the owner. And from here, for directories, I can just click and navigate through to move between these various directories, see the files that are within it. This little drop-down menu next to each of the files gives me the option to select for that specific file if I want to just view it in my browser, make edits with a text editor, rename the file, download it, or delete the file itself. The same thing can be done here with little checkboxes on the side. So if I wanted to go through and maybe copy these and copy them to a new location, I can simply tick those to hit the copy and move button up here. It'll give me the opportunity to copy. And then what it's going to do is it's going to say, navigate to the directory that you want to copy them into. So say I wanted to copy them in here. Just press copy, and it'll copy and drop both of those files into here. So along the top here is a lot of the specific buttons for controlling actions either with the checkboxes or for the directory that you're in. So the refresh is just simple. It's like a refreshing a page. It just queries the latest information on that directory that you're in. New file, new directory, basically do what they say. If I want to make a new directory in here, I can just type it out. It'll generate a new directory, place it within my location, and then I can navigate into it. Now, say I want to copy some data onto the system using an upload. In this case, if I'm already in here, I can just click the upload button and then click browse files, and I can upload some information from my local desktop here, and it'll upload it via SCP and place it directly into the directory. Same thing in reverse can happen of if I want to pick this and just download, it'll download and let me save it into any location on my local machine. So this gives, oh, yes.
I think someone's having an access issue. So in Zoom, someone said ondemand.arc.ubc.ca won't load for me. It says this site cannot be reached.
Okay. So I mentioned it briefly, but if you are trying to reach ondemand.arc.ubc.ca, if you're on campus, you need to either be connected to a campus landline network or the UBC's secure or EduRoam systems. That'll place you within the UBC networks. If you're off campus, you'll need to connect using the MyVPN to be on the campus networks. And this is basically the same way that you would access Sockeye as if you're using the SSH client. So if you're getting that message, I would check to see if you're on the VPN. If you're on the VPN and you're still having that issue, let us know. There may have been some issue that happened at UBC IT's level that we don't know about that's blocking it, but generally, if you're on the VPN, you should be able to connect and access to ARC OnDemand. So let's say, you just finished attending the Globus session and you have some Globus data that you want to move between various sites. Well, you could go into Globus and try to navigate through the folders, but if you're already working in, say, ARC OnDemand and you have something in here that you want to send over to, say, the Cedar system, we also have this Globus button here. And what this will do is it will connect to Globus and tell it to open one side of the Globus transfer as the directory that you're in on ARC OnDemand. So in this case, if I click, what should happen here is it will connect up to Globus. It'll tell me that on this side, I'm at the UBC ARC endpoint. And it's going to ask me to just verify my identity. And then it'll pick up here in the path and actually place me back in this MATLAB container folder that I'd picked while I was in ARC OnDemand on here. So that gives an easy way for if you're working in the ARC OnDemand interface and you want to quickly go to moving those files somewhere with Globus, we have an easy button to let you connect up those two interfaces seamlessly. So that is kind of the introduction to the file system. I'll pause here for a second and check the questions. Yep. Okay. Yeah. If anyone has any questions, please feel free to ask and let us know. And I'm happy to stop and walk through or explain some more. So now that we've wrapped up kind of how do we interface with files and how do we utilize that, we're going to look at the next section will be if I want to interface with the actual scheduler. So if you're used to working on HPC systems, you know that's a scheduled system. So jobs will go into a queue, and then you can view from that queue what your status of your jobs are, when they've finished, when they expect to start. And we have that same interface on ARC OnDemand. So if you go to the Jobs tab and select Active Jobs, this will pull up the queue, and you'll have the choice between just your jobs that are currently submitted. I don't have any, so it's not very interesting to look at. Or you can view all the jobs that are currently on the cluster. And from here, I can scroll through and look at our several pages of various data that's up here. And we can take one of these jobs and get kind of the basic information out of it that we would get off of the Slurm scheduler. So in this case, we can see what the job ID was, the job name, who submitted it, how long it's been running, what their time limit is, the resources, and when it's expected to end. And this is available for your jobs as well as anybody else that you can see them for. And in this interface, you can also tell your jobs and just your jobs if you wanted to cancel them or go into the directories where their files are. There's a quick link available here. I'll show that later on when I submit some jobs to the system, just so that I actually have an interface to work off of. Additionally here, if I wanted to say filter my list of jobs, so say I just wanted to know about GPU jobs, I could type in here and it would actually quickly filter and basically find every job that has either GPU in the name or GPU as the partition that it's searching for. So in this case, I can quickly look at the GPU partition and see, in this case, this running job here, about how long that it's been running. So in this case, somebody wanted to submit a job that was 7 days long, and it's about 5 hours into it so far. And in this case, it's just a completed job, and we can see that data on it that's been recently completed and how long it took. So now that we've looked at how do we interface with the scheduler to see what the status of jobs are, either ones that are running or ones that are still in the queue, we can actually also use ARC OnDemand to write and submit our jobs as well. So if we click on this job composer under the jobs tab, it'll start up an interface where we can write and submit jobs directly to the scheduler using the text interface.
Yeah, so there's a question on Slido is, can we also access and store data on the Chinook server with ARC OnDemand?
So the Chinook server only has an interface via Globus, but you can use ARC OnDemand to connect up Sockeye to Chinook via the Globus interface. So in that case, if I was to go back here to the files and go to, say, my Scratch, where I'd have some output data, if I wanted to go here and say, upload some data from my Scratch folder, I can click on the Globus button. It would take me in here, and I could pick my files on this side for Globus, and then for this one, I'd do an endpoint, and I'd pick my Chinook endpoint and place it on the other side here, and then initiate the transfer for Globus that way. Same thing with the other way around. If I wanted to use Globus to transfer back, I can use the same method to go where I want to transfer it to. In ARC OnDemand, hit the Globus button and use Globus to initiate the transfer. So when I'm working with jobs on ARC OnDemand, what I can do is I can either create a new job from scratch, or I can use some of the templates that we provided. So in this case, if I wanted to create a new job and use one of the templates, I can click on the templates at the top here, and I can see various templates that are all based off of the same job templates that we have in our user documentation. So in this case, I'll just pick a simple GPU job. And we can see down here, we have a template, and I want to create a new job. I'm just going to call this I'll click this and it'll create it and set it up over here. And then I see the question on Slido. So
I think it's a follow-up or something very similar to the question
Yep.
that we had earlier. So it's, do you need to transfer the data, or it could be a symbolic link or mounted as a drive between Chinook and Sakai?
So in this case, you do need to transfer the data. We don't have a direct interface from Sakai to Chinook outside of using Globus. So it would need to be transferred from your Globus endpoint to the Sakai endpoint if you need to pull that data down. So there is no, you can't set some sort of symbolic or mount point on Sakai directly targeting Chinook. It does actually need to be physically transferred between the two. So now that I have my GPU job set up here, I can scroll down and I can see that it has a submit script. And this is just a basic script that's from our template. And unfortunately, it has a lot of default values and such that need to be rewritten. So in this case, I can hit open an editor and it'll actually take me to a web interface to edit the text file itself. So in this case, I can go through and I just rename some of the sbatch commands. Set my account. I'll need 6 for this. And I only want 1 GPU in 2 hours. And personally, I don't use email to let me know when my job starts because I imagine that they're going to start anyways. So in this case, I can just go through and I just do this. I'm not really using much for the GPU itself, but again, this is just a test job. Oh, yes, yeah. That's fine. Yeah, this is also one of the just basic commands that come in here. So this would be actually cd2 80 arc1, something like that. So I can save this, and then when I close out of the file editor here after saving, it'll actually update on the screen itself here with the updated text file. So now that I have it written, maybe I'm doing something actually more interesting than just printing out some text to the screen. And my job's ready to run. I can simply just go up here and hit submit. And it will submit the job and put it into the queue itself. And if I'm lucky and it doesn't start immediately, I can actually go back here to active jobs and sort it just down to my jobs. And we can see that it is actually queued here. So same information I just put in of 1 node, 6 CPUs. Oh, and it just started running. So down at the bottom, we can also see that since this is just my job, rather than just having the information, I can also do a few actions with it, which would be canceling the job itself, opening this location in a terminal or in the file manager. So if I open it in the file manager, I can go here, you can check my output, and I can see it printed test, just like I asked it to. So in this case, we can write pretty much any job script that we would through the command line in the interface here, and I'll do the same submission as we would via SBatch to start up a job. So this makes it a lot simpler rather than having to edit the file in the command line using nano or something, and has a bit more of like a natural feel to clicking around and using a text editor. Yes.
Question over Zoom. So can we request more GPUs, and how can we select the 16 GB or the 32 GB node?
Yes. So for this example, because it is just using our standard Slurm script, you can make those requests. So in our case, if we wanted to request more GPUs, if I open the editor here, go back in, I can just simply, instead of pick 1 GPU, I can do 2. And if I wanted to select our 32 GB node, it's SBatch minus C, and then GPU mem32. Let's see if I remember this off the top of my head or not. If not, it is in our documentation. So let's see if I'm correct on that part. Where's our... Yeah, so it's constraint GPU mem32. I think capital C is equivalent, but in this case, if I was to just put this into my job script here, this would give us our 32 gigabyte memory GPU. And I can just save that out. And if I go back here, close out a few of these tabs, we can see that it's updated with that constraint. And if I submit it again, it'll be constrained to just run on those 32 gigabyte memory GPUs rather than being able to be dropped between the two of them. So this gives us basically an easy way for us to write the same job scripts that we would if we were on the command line and interfacing with it, and say we have our software already set up. Well, what if I do want to use the command line? Well, we do have that option as well. So if you go to this clusters, we have underneath it a Sockeye shell access button. And this button will actually just open up a full-on SSH shell to the system itself, much as if you would if you use an SSH client, either say Windows, Linux, MobaX term, any of those, you get the same effect. This one is just in the web browser and you don't have to install anything ahead of time. So it's a little easier to access. And from here, all of my standard commands work. So if I need to do some command line work or run a tool to do some pre-processing, I can do that through here. And later on, when I go through some of the interactive apps, I'll actually use this command shell to do some preparation for both Jupyter and RStudio workloads. Now, this option is not just available through clusters, but say I see my job in here. This is actually finished, just hasn't updated yet. But I want to go and do some work with one of my finished jobs. If I click on Open in Terminal, it'll actually take me to the path that I had my job running at. So it'll drop me directly into that path without having to first jump in and then navigate to wherever that job was. And the same functionality is on most of the various tabs within ARC OnDemand. For example, if I was in Files and I wanted to work on my project, we also have this Open in Terminal button. It'll do the same thing of opening a terminal here that places me into my ARC project. So it makes it very quick and easy to navigate around, jump into the terminal where you need to, and then do other interfacing and such through the graphical front end here, where it makes sense and where it's easier for you to work with. Before I get into the next section here, are there any questions or anything anyone would like to ask? All right. So this last section is kind of one of the real big additional features that we get out of Open OnDemand. Everything that I've shown up to this point, you can already kind of do in the command line if you have sufficient knowledge with Bash and kind of navigating through it. These interactive apps, in addition to submitting jobs and such, will actually start a full graphical session and forward it directly to you. And for some applications, this was possible. On Sakai, it just required a lot of extra overhead with SSH forwarding, setting up an X session on your local machine, and then connecting everything together. Everything here for the interactive apps now is made much more streamlined and is all set up to run within the browser. So you don't need any additional software or any preparation to handle it. So to start with, I'm going to go to looking at a Jupyter notebook. So in this case, if I go in to look at the interactive app, I'm presented with this form that gives me a couple options. The first is an allocation code, and this is basically just picking whether I want to use my CPU or GPU allocation. And then I'm given the option of either starting a full Jupyter lab or just a Jupyter notebook. Then I'll get how many hours do I want to run this Jupyter lab session for. And for all of our interactive apps, the maximum runtime is 24 hours. And this is simply to kind of focus on ensuring that if you want an interactive session, you won't be blocked for too long if the system is quite busy. If we allowed full 7-day sessions, there absolutely will be a number of jobs that people would start it up and they would run and it would take up a slot for all 7 days. We do have a limited number of cores available for interactive sessions. So we wanted to, because of that limited resources, we also limited the amount of runtime. And we assume that 24 hours is probably long enough for you to do something that you would physically want to sit in front of your computer for. If your professor makes you sit in front of your computer for 24 hours, you shouldn't. But then after we select the amount of time, we can select the node type here. This should correspond to what you picked for the allocation code. And in this case, we did have the question a bit earlier on if I can use 32 gigabyte GPUs. Right now, we only have supported the older 16 gigabit GPUs on this mode. If you need the 32 gigabit ones, you will need to submit a full SBatch script either through the command line or through the interface that I talked about earlier on Open On Demand. These ones are at the moment just 16 gigabit. We are looking at adding the 32 gigabit ones here in the future as we have the resources available for them. And if you do need it, please still let us know because it helps us keep track of how many people are interested in using an interactive workflow with a 32 gigabit GPU. Finally, because I select a CPU, I need to pick how many cores I want to run for this notebook, and each core comes with 4 gigabytes of memory. So if I need 4 cores, I'll get 16 gigabytes of memory. If I need more memory than that, say I actually needed 32, even if I'm not going to use all of those cores, I'd pick 8 cores because it'll give me 32 gigabytes of memory. This last button here, if you tick this, will just send you a very basic email letting you know when your session will start, and it will go to your institutional email, so your cwl@mail.ubc.ca. Once I click launch, it'll produce this card letting me know that the job is currently queued and it's waiting for it to start running. And it gives me a little bit of the information about when it was created, how long the job will run for once it starts, as well as the session ID, which is a link to basically the startup script for it. Once it starts running, the card will change dynamically just like it did and say go from queued to the running state. And it'll list at the top here how many resources I have, where it's running at as far as a host, and then give me this connect to Jupyter button. So this button, when I click it, will go ahead and open a new tab and give me a full Jupyter interface here. And from here, if you need to interface with your directories and such, we have your home directory here, as well as things like, say I wanted to start just a new notebook. I can just do this to import sys. Yes.
The question is, if I run into a fail to submit session, SBatch error max. Are you able to see it?
There's I can
the error
see it.
code. Yeah.
Yep. Okay. So it does. Let's see. Associated max job submit limit. So I'm going to guess, given that message, your PI forgot to renew your sockeye allocation, which did happen here at the start of the month. By default, if your PI has not renewed at the start of the month and the year comes to the end, then we set all of the job submission limits to 0. So most likely, what you want to do is talk to your PI and make sure that they did attempt to answer one of the several emails that we sent out reminding them to renew their account. Because I'm going to guess if you're hitting job submit limits, you cannot submit jobs because your allocation is currently inactive. So in here, we have just a basic Python environment. Now, this Python environment is very simple. It doesn't have much loaded for other things. So like if I want to do import NumPy, I haven't actually, I get it installed NumPy. Okay, I'll do import torch. So this will use whatever your base environment is on sockeye. So if you pip installed like I did and forgot that I did it, NumPy, it'll load that up. But if there's not something else there, or it's in a different virtual environment than what you're interfacing with, it'll give you the error saying, oh, I don't have this package. And unfortunately, our compute nodes that all of these Python notebooks run out of do not have outbound internet access. Only the direct login nodes do. So if we wanted to go through and say, I need a new Python environment because I want to set up an environment for running a set of Python packages. Well, if I can't do it in the Jupyter notebook, I can close out here and end my session. We do have a way that you can go through and set up your own Python environment. So I did this earlier. So I set up a NumPy environment here, just called this NumPy Pi 312 one. So if I wanted to do another session, let's say I want to create one that has Python 3.11. What we can do here, second. So we do module load, GCC, miniconda. Oh, miniconda 3. And then within here, I want to do conda create -n. So what this will do is it'll create a new conda environment, just like I would when I'm creating a conda virtual environment, and tell it to load the IPy kernel, which is important for Jupyter, and build with Python 3.11 rather than the default 3.8 that's on the system. So what will happen is this will go ahead, it'll run through and do its kind of base setup, build an environment, and then I can activate that environment, go in and run pip to do installs for any packages that I want. This might take a little bit of time for it to run through, but you can use this for basically getting whatever packages you want into your Jupyter notebook that you would run through the interactive session. Yeah. So once this is built up, we'll just go ahead and just do a pip install for NumPy, and we'll be able to load up the environment and set it up here. All the instructions for this are on our technical user documentation as well. I just wanted to walk through because I figured if you're interested in using Jupyter notebooks, a lot of times you're also probably going to want to use your own virtual environment as well and set that up. So the reason this is working, whereas it wouldn't work on Jupyter, is Jupyter is running on our compute nodes, whereas the shell that you open off of Open On Demand is on one of our login nodes. So in this case, the shell does have outbound access to the network to download packages and such. And that's why we need to jump into that shell rather than doing everything within the Jupyter notebook itself. Yes.
Chika, we have a follow question from Tony. It's the participant on Zoom who had that error code. So he mentioned that he checked with his PI and apparently they renew Sakai on July 8th.
Okay. In that case, I would uh, probably open a ticket with ARC support to see if either your account hasn't been updated and renewed yet, or there is some problem after the fact where we didn't add back your ability to submit jobs. It might be that it just hasn't been processed yet because after the renewal, we do have to manually process everything after July 1st. So yeah, sorry that you aren't able to follow along with the session because of that, but that is, I'm pretty sure why you're unable to submit jobs right now is you had your account went inactive on July 1st. So now that we have our Conda environment set up, because I haven't actually set up a Conda environment before, I just need to resource my -rc. So it creates a little entry in there to start up Conda. Now I do Conda, activate my NumPy env 3.11. So it placed me in this environment, and I run Python m ipy kernel install user name. And this part here basically just tells Python to initialize the, I need 2 dashes. Tells Python to initialize the Jupyter interface and write a couple things into the home directory so that JupyterHub knows where this virtual environment exists. Finally, I'll just do pip install NumPy. So I actually have a NumPy installed. And this part should hopefully be a lot faster than the other part where it sat around for a little bit. But what this will do is it will set up that environment for me, and then I can just go back to my interactive sessions here and start up a Jupyter notebook. So if I do the same thing again, I go to launch. Once we have NumPy installed here, once this starts, we should see a new environment that can be loaded as part of the kernel when starting up Jupyter Notebook. So now when I connect to Jupyter, you can see it'll start up here. Appears to be running kind of slow. Yeah, there we go. We can actually see here, I can start up a new notebook with my NumPy env 3.11. If I go in here and do import NumPy as np, do np version dot. full version, we can see it is the 2.3 that I just installed earlier. So we can do this as basically a way to set up our NumPy or our various virtual environments, load them into Jupyter, and then continue working on them in Jupyter notebooks on the Sockeye system as part of interactive. So that covers the basics for pretty much what we'd want to do with Jupyter. Can finish up there and look at our other major application. And this one is RStudio. So if you're familiar with RStudio, there's a number of different versions, and we support 4.23 up to 4.50. And we offer this as kind of an option versus in Jupyter where it's just one version of Jupyter. We know that R and RStudio users will often come with their own packages, and those packages may be dependent on very specific versions of R. So we wanted to support a wide range of modern versions of R that will hopefully support the versions of packages that researchers want. So once we select the version, it's much the same as what we do in the Jupyter notebook. Select your allocation code, node type, how many hours, how many cores. We can launch. And from here, it'll start up again with pretty much the same interface, but for RStudio rather than Jupyter, obviously. So if we connect in, we should be getting our RStudio interface, and we have everything here that we'd want to interact with. So I could go through the kind of same process of setting up a virtual environment and how we do that for RStudio, but it's a bit long-winded, and we do have all of that information up on our website under our documentation. It is much the same process of you connect to the shell environment on the login node and go in here and then set up your environment and then load that in after you've downloaded all the packages and pull it in on R. Unfortunately, I'm not much of an expert in R, so I can't really show off too much here as far as what it does, but both of these are commonly requested for a lot of researchers, so we offer those as our first two interactive applications that we have available on ARC OnDemand. We are looking at adding a number of other ones. I know because I'm personally working on it, getting MATLAB up and working is kind of our next major goal for an interactive application, as well as a number of other ones that we'll be introducing here throughout this year. But in addition to these, we also kind of have a catch-all, which is this cluster desktop application. So unlike the other two, cluster desktop doesn't launch a specific program. What it launches is effectively just a Linux desktop that is within your browser. So in this case, if I want to launch, I can do my standard fill out the form and everything again. And in this case, because the software that I want to show off needs more CPUs, I'm going to request 16 instead of just 4. And rather than being launched directly through the web browser as just a web front end, what this will actually do is it'll start up the cluster desktop session, and you'll be able to connect to it through VNC. Open OnDemand provides a VNC viewer as part of its interface where it is in the web browser. But if you are more familiar with using VNC and have a local VNC client, we also offer an option for connecting to the remote desktop over your own VNC client. Those instructions on how to do that are here under the native instructions. But for this session, I'll just be working with the native one that's in the browser. And since this is a VNC session, rather than direct connection with the web browser, it does have to do some compression and image quality based off of what your network capacity is. And when you click on it, it'll actually open a VNC viewer directly to a Linux desktop, which is what we have here. And we can see here, if we open like a terminal on that Linux desktop, we're actually on SE239, which is one of our compute nodes. Once we're in here, oh, yes.
So there's a question from Zoom is, do you know if SPSS is available as one of the interactive app or available via cluster desktop? Thank you.
Unfortunately, I'm not familiar with SPSS. If it is something that would run on a standard Linux desktop as a graphical environment, it should run under this cluster desktop application. I'm going to show off just loading a piece of software that I know a bit more about. But if you have something that has like a standard graphical front end, it should run within this cluster desktop. So in this case, yes, we have kind of like the standard Linux desktop. This is running the XFCE cluster desktop, or not cluster, but just desktop environment. And from here, I can browse through like my home files and such, see what I have here. If I wanted to maybe edit something with a text file, you can open it with the text editor, work on it here. Or if I have, say, some graphical software, which I did go and install a little bit earlier, we'll see if this works, because I tried it an hour and a half ago and it worked great. And now that I'm on the screen with everybody recording it, it might not. But this is Blender, which is a 3D modeling and graphics software. Not exactly your standard research environment software, but it is a good way to show off kind of the graphical capabilities of Open OnDemand. So once this loads up the interface here, we'll get presented with kind of a 3D viewport as well as the standard interface. And this is the part I've noticed that takes the longest time, is this initial startup. And wasn't able to figure out why, because it did start really fast sometimes, and sometimes it takes a few minutes. But while that's starting up, I can kind of go through what you can do here with the graphical desktop. So in addition to like running actual software itself, if you don't need to have a network connection for installing a piece of software, you can do a graphical installer on our compute nodes as well. So say maybe you have a copy of, trying to think what doesn't need a network connection to download stuff for the installer. Maybe ANSYS or COMSOL does have an offline installer. But if you have one of the software packages where you need to like click through, make some decisions and such, that can be installed using this cluster desktop on our compute nodes, as long as it doesn't need to reach out to the external network.
Samuel has a question. So Samuel is the person who asked about SPSS. So his question is there any plans to provide cluster desktop with Windows in the future?
Okay. So this is something that right now we don't have direct plans for, but it's something that I've run across when looking into more options for Open OnDemand, which is Open OnDemand and our cluster all run Linux. So the only way that you could have a Windows machine is if you had a Windows VM that ran on Linux. This is a bit of a complicated interface, especially for researchers to want to set up themselves. But there are a few people who have done some work with Open On Demand and having a Windows desktop running a VM connect to Open On Demand. So it would be possible in the future, but at this time, we don't offer direct support for any Windows-only software on our system.
There's another question in the chat is, where's the Sakai working directory in this desktop?
So in this desktop, your working directory is just your home. So it'll drop you into your, effectively run the job out of your home, start up the session. It is technically at a specific location here. So like if I click on this session ID, it'll actually take me to my home, this big long string of stuff for the session itself. But the session itself runs as though you were running out of your home directory. And because these sessions run off of our interactive nodes, they are, you can actually do writing and editing files within your home directory. We'll see if this finished loading. Hey, it did. Okay. And the graphics are not great. But it does spin. Okay. The graphics are not great. Part of that is my monitor and these displays are not the same resolution, so it kind of garbled it a little bit. But it is actually fairly fluid, which is what I was hoping for. So this is, yeah, it's a 3D software. If I wanted to move this cube, and just click and drag it, move the cube around. I don't know how many people are familiar with Blender, but it has a lot of tools for any sort of 3D modeling. So if I wanted to like grow my cube, such here. One thing to note for a lot of software is if you have something that has like reasonably intense 3D graphics like this, it does have to do software rendering, as our nodes do not have a GPU on them outside the GPU nodes. So make sure that one, your software handles software accelerated OpenGL, and two, as I found out when I was testing Blender, make sure you give it enough CPUs. I tried running this with 4 and it was very slow. So in this case, 16 actually runs pretty well and is pretty smooth. So test out your software if you're doing 3D work and see what sort of specifications might need to be added for it to have a smooth experience. Once we finish up with this, and just close, I'll just bring up this part. If I close out of, say, my VNC session, but I wasn't actually done with it. If I go back here to my interactive sessions, you can see it's still open. And it doesn't end the job when you close the tab. It only just closes out the VNC session. So I can just open it back up and I'm right where I was left off with. If you hit this delete button though, it will actually end the session, close out any open windows you have, and basically finish up the job with the desktop itself. So once that's finished up, our last little bit here is we do have a quick link for if you'd like to email ARC support because you have an issue or something that comes up, or if you need to visit our online documentation about ARC OnDemand and Sakai in general, we have a quick link here as well. With that, that's kind of the end of what I have for Open On Demand. Are there any questions or anything that people would like me to go over or expand upon? All right, if not, I will take it back over to the presentation here. And this is our survey for our courses. This one is unique from the one that I had at the start of my session. This is just for this ARC OnDemand session. If you fill this out and give us your feedback, you'll have a chance to win $25 Amazon gift card. And I'll leave this up here while I'm doing questions, unless I need to go to the window or something to show off. So yeah, if you have any questions, please let me know. Otherwise, thank you for coming to the session.
Hey, Jacob. So everyone, please be kind and fill out the post-session survey. Let us know how we did. There is an Ask Me Anything session tomorrow afternoon, so you kind of call back and feel like, okay, I have this question that I forgot to ask during class. Feel free to join that session tomorrow afternoon. With that, thank you so much.